Hi, my name's Steve, call sign G0FFB, Golf 0 Fox Baker. Okay, today I just want to briefly cover collinear antennas. Collinear antennas you'll see in all villages and towns, cities where radio amateurs live. Essentially they're the workhorse antenna. They're very good at distance and they're very good close to if you wish to speak with friends. They're used on FM, which is known as the vertical mode, and this is one here that I made 25 years ago. The white tube is just for weatherproofing. This one was up in the attic, so I didn't need too much, and it's a prototype vertical. These are simulating the Earth, and they're quarter wavelength long, and I believe, I may not be factual here because 25 years is a long time, but I believe there's also a sleeve in there acting as part of the earthing system, the antenna system. Right, how does it work? Let's crack on. Well, we know if we have a half wavelength, that magic half wavelength again, and then we need to give it an earth return of the same half wavelength, effectively making a dipole. So we know that we have one half wavelength of coax, measure it out, then we have to match it with another half wavelength to complete the circuit. Now imagine if we could take that one half wavelength and we could say we're not just going to have one, which would work quite adequately, but now we want 2 or 3 or 4, 5, 6, 7, 8, 9. Every time we add a half wavelength, stack them on top of each other, we're adding gain to the antenna. And every time we add gain, those angles of radiation are going down and down and down. So the more gain an antenna has, the further distance we can get, because our antenna is directing its radiation lower and lower towards the horizon. Now, most of these white stick antennas that are all over the place, as I say, they're made this way, and they use a piece of coax. So the coax comes up, fed from your Baofeng with a PL259, comes into the antenna, comes up to there, and then the earth or shield, whichever you call it, comes to these two pieces of coax and some copper tubing in there. And the middle, and it also goes to the earth shield of the coax, and the middle of the coax will go to the middle of the element that measures a half wavelength at this frequency, and the earth shield will go to the earth shield of the coax. When we get to this top end here, we have the shield earth again, and we have the inner conductor. Well, now we will measure another half wavelength of coax, and now we will swap over the earth and the centre conductor so they're the opposite way around for one half wavelength. And then we will have a third element, and guess what? We swap them back. So then we have a 3-element vertical antenna, with each element increasing the gain of the antenna. So theoretically, and I have done it on our boats, you could have a 30-element antenna or a 33-element antenna, a super gain antenna, and your signals would be so low to the horizon, it'd be unbelievable, but practically impossible. On a boat, I made one for the NOAA satellites that was the height of the mast, and I think it was on VHF, not UHF. This one is UHF, but it was on VHF, and I think I managed 9 elements, and it worked brilliantly. And I didn't have this sort of matching arrangement to make the magic happen. I used the J-pole and the Slim Jim matching. I used a quarter wave stub, so I made at the bottom where these two are a small loop that went down 1/4 wavelength of the frequency, the VHF frequency, and then I matched the elements by moving the coax up and down at the quarter wave stub. And it worked very, very well, extremely well. So if you want to make one of these, look up coaxial collinear antenna radio, and it will show you how it works in more detail if you're interested, and how to make them. As always, it looks easy, but it's a lot more difficult than you think, which is why I'm still interested in antennas even to this day, because every time I think I've seen it and know it all, I find something I don't know. My name's Steve, call sign G0FFB, 73's for now.